The short video will take you through the answers to question 2. Right, let's get going. 211. Name the homologous series to which compound C belongs. There's compound C, and we can see it's got a carbon-carbon double bond, so that means the homologous series is the alkenes. The letter that represents a secondary alcohol. Compound B has got an OH group, so that's an alcohol. And compound G also has an OH group. And when it's written in that form, it's very hard to see the compound, so let's draw it out. CH3COH, there's the alcohol group on carbon 2, and then CH3. Now, to determine whether it's a primary or secondary alcohol, you have to look at the carbon containing the OH group. So if we go back to to compound B, there's the carbon holding the OH group, and it's attached to just one other carbon, which means it's a primary alcohol. Compound G, there's the carbon holding the OH group, and it's attached to two other carbons, so that means it is a secondary alcohol, and so the correct answer to 212 is compound G is a secondary alcohol. 213, functional group of compound H. There's H, it's methyl propanoate, and that's an ester, and so the ester functional group is the C double bond O, single bond O, attached to another carbon. 214, the repeating unit of compound F, it's polypropene, and so if we draw out propene, then we have it. 3 carbons in a chain with a double bond between 2 of the carbons. When it polymerizes, it does so by addition polymerization, so the double bond breaks as the monomers join together, and so that then is the repeating unit. And then finally, 215, the general formula of compounds belonging to the same homologous series as compound E. E is propane, so it's alkane. And the general formula for an alkane is CnH2n plus 2. All right, 216, letters that represent 2 compounds that are isomers. The best way to do this is to write the empirical formula of each compound. So let's go ahead and do that. A is C3H6O, B C3H8O, C C3H6. We're just counting the number of carbons, hydrogens, and oxygens in each compound. D is C3H6O. Propane, you could draw it out if you want to, but it's pretty easy, C3H8. The alcohol, C3H8O. What's that? 1, 2, 3. That's propan-2-ol, or 2-propanol, is C3H8O. Methyl propanoate, best to draw it out first. There is the structure of methyl propanoate, and its empirical formula is C4H8O2. I haven't bothered with polypropene because it's a polymer. It has no discrete empirical formula. It's obviously a very, very long compound. So to determine which are isomers now, you simply see any 2 that have got the same empirical formula but different structural formulas. And so A and D both have the empirical formula C3H6O. And B and G also have the same empirical formula, C3H8O. So either of those 2 pairs would be isomers. 217, compound most likely to have a sweet fruity smell. Those are the esters, and so that's methyl propanoate, or compound H. The UPAC name for the major product of the reaction between C and hydrogen bromide. C is propene. So it's an addition reaction with hydrogen bromide, and so the double bond breaks. And this is a Markovnikov problem. You have to decide where the H goes and where the Br goes, and the rule states that the hydrogen goes on the carbon that already has the most hydrogens, so that's carbon number 1. So the hydrogen would go on carbon number 1, the bromine on carbon number 2. And so if we're going to name that compound, it would be 2-bromo-propane. 219, name the unstable poisonous compound formed when compound E burns. That's propane, and it burns in a limited supply of oxygen. In abundant oxygen, it forms carbon dioxide, but in a limited supply of oxygen, it's going to form carbon monoxide. Right, 2.2, write a balanced chemical equation using full structural formula to represent the reaction that forms compound H. Compound H is methyl propanoate, the ester, and so that would require methanol to react with propanoic acid. Remember to have the bond between the oxygen and the hydrogen, and that then gives you methyl propanoate. There's the ester functional group, a methyl branch on the propanoate. Don't forget that water is also formed, and they're wanting full structural formula, so you need to show the bonds in water. 2 and 3, the catalysts that's used for this, that requires a concentrated acid, and we most commonly use concentrated sulfuric acid. Concentrated phosphoric acid would also work, so that would also be a correct answer.